The icosahedron provides the most interesting and well-known stellations of all the platonic solids. You start, as always, by making the stellation diagram. In this case, it's built from the 18 faces that intersect with our base face. Now we can see the regions that can be used to build stellations. To keep things clear, I'll use numbers for the regions. Region 0 is the central triangle, Region 1 is the ring of triangles around it, and so on, all the way up to Region 14. I'll keep the stellation diagram in the corner for reference, and highlight the selected regions for each stellation, showing the numbers of the selected regions beneath. Region 0, of course, merely recreates the original icosahedron. Region 1 produces the first new stellation. This is an icosahedron with a pyramid built on each face. It's similar to the Catalan solid, the Triaches icosahedron, but here the pyramids are higher. Region 2 creates this figure. Externally, it's the same as the well-known compound of 5 octahedra. This becomes clearer if we colour the faces of each octahedron differently. Looking back at the stellation diagram, you can see that region 2 is made up of 2 triangles, so the 20 icosahedral planes combine to give the 40 triangular faces of the octahedral compound. If we take region 3, we get this figure, but this is not a valid stellation. In fact, it isn't even a polyhedron, because the faces don't meet properly. It's just 60 diamond shapes. This shows that we can't simply pick any region, or any combination of regions, and expect a proper stellation. Only some combinations work. If we combine regions 3 and 4, we do get a valid stellation, this figure. Regions 5, 6 and 7 form this more complicated figure. And regions 8, 9 and 10 produce this striking stellation. Regions 11 and 12 lead to something you might recognise. The stellation diagram here is a single triangle, and that's the clue. This is the great icosahedron, one of the 4 famous Kepler-Poinsot polyhedra, made from 20 interpenetrating triangles. It's remarkable that all 4 of the Kepler-Poinsot polyhedra can be created as stellations of the icosahedron or dodecahedron. The outermost regions, 13 and 14, combine to make this spiky figure. It's sometimes called the final stellation because it includes all the outer regions. These 8 stellations form a natural sequence, built by taking successively wider rings of regions. But that's only the beginning. Many more stellations can be created by making more unusual, exotic selections of regions. This stellation is full of holes. Region 6 is coloured red in the diagram to indicate that the region faces the centre, so its reverse side is visible. This one has a highly complex structure. And this one has parts that are completely disconnected. The natural question is, how many stellations are there? This was first answered by Donald Coxeter and Patrick Duval in 1938 in a remarkable book listing 59 stellations. If you look closely at the stellation diagram, you'll notice that some regions have parts that are not mirror-symmetric. These can be split into 2 regions. Take region 5, for example. It's made up of 6 triangles. These 3 are the mirror images of the other 3. So we can divide it into 2 subregions called 5 left and 5 right. The same can be done with region 6, giving 6 left and 6 right. And likewise, regions 9 and 10 can also be split in this way. This means that instead of selecting the whole of region 5, for instance, we can choose just 5 left. When combined with other regions, this produces stellations that are chiral. They lack mirror symmetry. This is less symmetry than the stellations shown so far, but still icosahedral, so we allow them. Some of these chiral stellations are especially striking. For example, this combination of regions produces this figure. Its twisted, spiralling appearance is typical of a chiral stellation. This stellation is the well-known compound of 5 tetrahedra. This is one of the more complicated stellations. And this is the polyhedron modeller's nightmare, with numerous sections joined only at the vertices. In this video, I've covered only a handful of the 59 stellations. In a later part of this series, I'll run through the entire set. Thanks for watching. Please consider giving a like if you enjoyed it, and see you in the next video.